I've been exploring whether DrawExact, which is a browser-based drawing tool, might be useful as a teaching aid for subject matter where diagrams are central. Well, I suppose more specifically when diagrams kind of are the subject matter you're trying to get across. And I've been exploring this example, which I remember from my own school days, about the area of a circle. Let me show you what I'm getting at. How might we work out the area of this circle? Well, it might be useful to try and divide it up into different shapes, which make it a bit more amenable. So how about putting 16 segments in like this? And then we might try rearranging those same segments, which of course still have the same area, in a different way. And in this case, we somehow managed to arrange them into a rather lumpy rectangle. And it occurs to me that a rectangle is perhaps going in the right direction because we know how to calculate the area of a rectangle. But it isn't a rectangle, it's got these curvy edges along the top and the sloping ends. But I wonder if we use many more segments, that would not be quite the case. So maybe we should try 60 segments as an alternative. And what happens is this. So our hunch was right. If you use more segments, it gets closer and closer to being a real rectangle. And I suppose if we wanted to work out the area, we need to think about whether we actually know anything about the length, or the width I should say, and the height of this rectangle. So the width is made up of these little tiny curved arcs, and they're kind of half the circle. And this is the other half of the circle. So if it was a true rectangle, this length along here would be half the circumference of the circle, which is pi times r. And if these triangles were thin enough, because we had enough segments, this yellow line is the radius, but that would become the height of the rectangle in that situation. So then if we multiply pi times r again, we get pi r squared, which of course is the formula. It's quite a handy way of knowing where it comes from, getting an insight into it. I mean, that's an example that shows the area of a circle example, and I just want to make clear that I'm thinking about this, whether it would work for different sorts of diagrams. And this one, for example, is a completely different kettle of fish. This is something that might be taught at college level to computer science students. But it's the diagram which is what matters. I could go on endlessly for different sorts of diagrams that have come into my mind, but that's not really the point. I just want to leave you with that to see what you think, and I'd very much cherish your feedback.